Hey everyone! Hope you're doing well wherever you are in the world. Just to explain what this video is, this is a walkthrough for what we covered in section this week. And the reason we're doing this is that we know a lot of you have a lot going on right now, of course. Some of you are probably in other time zones even. So we want to make sure that you have every chance that you really can to absorb the material that we do in section and in lecture. So if there's anything else we can do also to help you learn, please let us know. But that's just why this video here exists. Now that we've gotten that out of the way, let's actually go through and learn something. So the first thing that we actually did in section this week was we reviewed a very important concept from 142 and 143. And this mainly is a difference between value variables and reference variables. So super fun, super important, so it's good to review it up front. And just a notation thing for y'all as well, I'm going to have code underlined that's just been run. Code that's underlined in main is going to be red, and then code that's run in a function outside main, or a function that's called by main, is underlined in blue. So just be aware what the difference in color here means. Alright, so let's go ahead and look at this example program we'll use to review. The first thing that's run in any Java program is, of course, main. That's review point number 1. So what's going on here? Let's say we've run main, and we've executed the first 3 lines. So we've made 3 different variables called x, y, and z. And immediately there's kind of a teachable moment happening here, because in my drawing I have sort of this box that's labeled with main, and I have x, y, and z stored inside it. And this is really the first thing I want you to remember about how Java works. Each function in Java, just like main, right, because main is also a function, each function in Java gets its own little area to store its variables. The technical kind of pretentious CS term for this little area is a stack frame. You don't have to worry about knowing the technical term. Just know that every function in Java gets one of these little scratch areas where it puts all of the variables that it creates. So that's point number 1 over here I want you to notice about what's going on here. The second thing I want you to notice is that these 3 variables we've created, x, y, and z, they aren't drawn exactly the same in main's little set of variables. They actually look quite different from one another. If you look at x, for example, x is just a box that has a 1 directly put inside it. What's going on with that? So this is sort of teachable moment number 2 about this slide, which is that there are actually 2 types of variables or data that exist in Java. If you have a variable that is among a very small set of types, usually representing numbers, like ints, floats, doubles, things of that sort, we refer to that variable as being a primitive variable or a primitive type. And you can see here that this int x is one of those few primitive types. It's an int. So what does a primitive type actually means? Well, in this case, and this is true for all primitive type variables, you can think of this x as pretty much directly being this 1, right? Like they're one and the same. So whether I'm referring to x or this 1, they are interchangeable. That's what a primitive type variable means. Just think of this x as being this 1. However, you'll notice that y and z are both drawn pretty differently from x. So what's going on there? Well, I told you that there's a very small set of types in Java that mean a variable is primitive, right? Things representing numbers, like this int here. But everything else in Java, anything that is not one of those few primitive types, including, for example, arrays, is something else. So any variable that is not a primitive typed variable is automatically a reference typed variable. And that's true for y and z here because array is not one of those few primitive types, which makes it a reference type variable. So y and z here, they're not really, boxes that have any things stuffed directly in them. Y and z are arrows, right? Or pointers or references. These are all synonyms for pretty much the same thing that each point to an object, right? Y is this arrow or pointer that points to this first array over here, and z is this pointer or arrow that points to this array over here. So, whereas you should think of this x as directly being this 1, you shouldn't think of y as directly being this array over here. You should instead think of y as being the arrow that points to this array. So later, if I do y equals something, I'm changing y. And because y is this arrow, doing y equals something later will actually change where this arrow points, not the array over here itself. So just to be a broken record for the last time, primitive type variable, pretty much something representing a number like an int or a double, means that, for example, this x directly is this value stored here, this 1. But with a reference type variable, anything that's not one of those few primitive types, the variable should instead be thought of as an arrow or a pointer to some other object, right? So y is the arrow, not the array. All right, let's do something super scary and call a function now from Java. So we've executed the next line of main here, foo, and we pass in x, y, and z as the arguments. So what the heck is going on over here? Well, I said earlier that every function in Java gets its own little stack frame, right? Or, less formally, gets its own little area to store variables. So just like main got one up here, foo gets its own little area of variables down here. All right, so what's going on here? Well, we passed x, y, and z from main to foo when we called it. And it just so happens that foo's arguments are also called x, y, and z. So first, when we call foo, and before we actually run any of the code in the foo function itself, we have to copy over the arguments. Well, great. Let's copy x over from main to foo. And because x is a primitive type variable, x directly is this 1. So copying x over to foo means we're just copying the 1, right? So now we have a 1 down here as well. However, when you're copying y and z over, it's a little more complicated, and this is where you have to be super clear on what's a reference type variable and what's a primitive type variable. With a reference type variable like y and z, right, these two variables are the arrows, right? They're not the arrays. So copying y over from main's variables to foo's variables means that we're copying the arrow, right? So I'm copying this y arrow down here. So now I have a second arrow in foo that points to the same place. And likewise, I'm going to copy this z arrow over to foo's set of variables. So now I have a second arrow down here pointing to that second array. If you weren't super clear on this difference, you may have accidentally thought that I'd have a new y array copied down here and a new z array copied down here. But that's not the case. I'm just copying the arrows because that's what y and z are. And that's what this little text down here is trying to explain. Alright, so welcome to 373. We've literally just called a function and there's already a huge amount of work that had to go into explaining that, but now we're going to do something even scarier, which is now that we've set up foo's variables, we're actually going to run the code inside. So let's do that. So the first line of foo is x equals 2. So looking at this drawing before I showed the solution here, you may have had a brief moment of panic because there's an x up here and there's an x down here, and you may have gone, oh my gosh, which x is actually going to change? That's a totally understandable confusion to have. And I'm going to introduce a new thing now that you should remember about Java, which is that each of these little areas for variables that each function has, right? Main has its box or its area up here, and foo has its area or its box down here. Each function only knows and can only see the variables that are in its box, right? So foo only knows about the existence of this x, this y, and this z. And when we're in main can only see this x, this y, and this z. So now if I'm inside the foo function, right, and I'm running the code inside there, when I do x equals 2, foo only knows about the existence of this x, so this x is the one that's going to have to change. That's why this one went to 2, and this x up here in main didn't change, because foo can see this x, but it doesn't even know about the existence of that one. Alright, so that's cool. Then in the next line of foo, I'm going to assign y to a new array of numbers now. And for the same reason as this x changed on the previous line, this y down here is changing now because it's the only y that foo knows about. But there's something a little more subtle here happening, right? So x was a primitive type variable, so we just assigned it a new value, because that's what x is, right? It's directly the number stored in this box. But y is a reference type variable, right? So when I'm doing y equals something, I'm changing y, which is this arrow over here, right? If we back up a little bit, you may have thought that doing y equals some new array would actually change what this array is, but that's not the case. Y isn't that array. Y is the arrow or pointer that points to this array. So when I do y equals something, I'm changing what the arrow is, because that's what y is. It's the arrow, not the object. And specifically, I'm creating this new array of 1, 2, and 3, and then I'm changing y from pointing up here to instead point here. So make sure that you understood what I just said. If you don't, feel free to pause and rewind the video. But this is a super important thing you should understand, and it's why reference and primitive types are so important to really wrap your head around in Java. Alright, so assuming not all of you are screaming at your computers right now, we're going to go ahead and run the last line of foo, and we're going to assign z at index 0 to be equal to 5. So again, we're running this code inside foo, so foo only knows about the existence of this z down here. So we're going to go, great, okay, we're doing something to z. Where does z point? Cool. We're going to follow that pointer or that reference. Z points to this array over here. So I'm going to take this specific array that's pointed to by z, and at index 0, change the value to 5. So that's what that looks like in this box and pointer diagram we have here. And then we are done. We have finished running foo. Foo was the last thing in main, and now we're done and life is great. As a quick note also, don't feel bad if a lot of that seemed really complicated to you. This is definitely a very complicated topic we want you to remember from 142 and 143, but definitely do try, to go back and rewatch the video if that confused you, because this is kind of a bread and butter thing that you will run into all the time in your projects. We've all seen lots of bugs that came up when students didn't understand primitive types versus reference types. So again, don't feel bad, it's a really hard thing to learn, but do rewatch the video until things begin to make sense to you. And feel free to post on Piazza if you have questions. So I assume if you got here, you kind of rewatched that video until that primitive and reference type thing made sense to you. Again, don't feel bad if it felt like it took you a while to wrap your head around it. It is a complicated thing we want you to remember, and that's why we're doing this review in section. But now that you've kind of understood that, I want you to go ahead and try a problem on your own. So if you're looking at the section worksheet from the website, we have a bunch of problems on it. Your TA may have done either 1.1a or 1.1b in section. They're both pretty similar. In this video, I'm going to focus on 1.1b. So go ahead, give this a shot, do it on your own. Feel free to pause the video while you're working on this. And when you think you have a pretty good idea of what the answer is, or when you get stuck, feel free to unpause the video and keep watching from there. So I'll give you some time to do that. Alright, I'm going to go ahead and imagine that you all have unpaused the video now and you're good to go. Let's go ahead and review this problem. Alright, problem 1.1b. This is testing that primitive and reference type stuff we talked about in the slideshow. So let's look over here. So in this example problem you just did, we again have a main function, which is the first thing that's ever run, and we've just executed this first line of main. Again, code that's underlined in red has just been executed in main, and code that's underlined in blue is run from functions called by and outside main. So just remember that. So anyway, the first line of main makes this new variable p. Cool. So we're going to remember that each function in Java has its own little area for variables, right? So we're going to put p in main's area or box. That's point number one. And then the second thing is we're going to look at the type that the variable p is. So p is of type point, which is a class that we declared sort of in the problem when we're using. But point is not one of those few primitive types, right? It's not an int, a double, generally something representing a number. So because point is not a primitive type, it's automatically a reference type, which is why we draw this variable p like this, right? We don't just directly stick this point object inside p's box. P is a reference type variable, which means that you should think of p as instead being the arrow that points to this object, not the object itself. Cool. So that's the first line. We haven't gotten any output yet on the terminal window, but let's change that. So in the second line of main, we're going to print p, right? So in main, we're going to look at its set of variables, find this variable p, see where this reference variable points. Oh, cool, it's this object over here. So now I'm going to print out this object. And when you print out an object in Java, you're actually going to call its toString method and print that. And it just so happens that when we print this point object, its toString method returns 11 and 22. I'll try to not have that hidden by the Google slide thing down there. There we go. So great, that's the second line. If you're confused or stuck already, feel free to go back, but I'm going to kind of keep chugging along. So on the third line of main, we're going to create a new variable, int n, and set it equal to 5. So again, n goes in main's set of variables, because that's just, them's the rules of Java. But n now is an int, right? So an int is one of those few primitive types that we talked about. So instead of having some weird arrow coming out of n, we're just going to put this 5 value directly in this box here. And as is the case for all primitive variables, you should think of this n and this 5 as being exactly the same. They are interchangeable. So if ever I copy or reassign n, I'm directly just going to change this 5 value in the box. Or directly copy it in the case I am copying it. Alright, 2 variables in main, 1 primitive, 1 reference. Let's call some stuff. So we're going to call mystery now on the 4th line of main. And before we even run mystery, we're going to do that, a setup that's similar to what we saw in the review slideshow. Mystery is a function, and just like every function in Java, it gets its own little area to store variables, and we represent that by this box here, right, with this label. And then, we're calling mystery with the arguments p and n. It just so happens that mystery's arguments are also named p and n. So we're going to copy n from main over to mystery. Because n is a primitive typed variable, it directly is this 5. So copying n over means just taking this 5 and copying it down here into mystery. So that's good. And then when we copy the p is instead a reference type variable. So copying p means copying this arrow over from main to mystery. So just to be clear, we haven't actually run any of the code inside mystery yet. We're just doing the setup to pass the arguments. Alright, groovy. Now let's actually run the mystery function. On the first line of mystery, we're going to set n equal to 0. And you're going to recall what I said earlier about mystery only knowing about this n and this p, because these are the variables that are in its box, right? It only gets to know about the existence of these two. So when I do n equals 0, it has to be this n down here that changes, not the one up here. On the second line of mystery, I'm going to do p.x equals p.x plus 33. What's going on there? Well, mystery is going to look at its p variable, because it's the only one it can see. It's going to follow this pointer, or this arrow, because it's a reference type variable, and arrive at this object. And then once I have this object, I'm going to increase its x value by 33, so it goes from 11 to 44 now. And finally, I'm going to have this print line call inside mystery. So when I do p.x and p.y, I find out what those are by going to the p variable, following the arrow over to this object here, and then printing out this x, which is 44, and printing out this y, which is 22. And then in the last part of this print statement down here, I'm going to print n, and of course, because mystery only knows about the existence, or can only see this n, that value is going to come out to 0 down there. So go ahead, feel free to pause and go back if anything's lost you. If not, we're going to keep on chugging through this. So on the next line of main, because I'm done with that mystery call now, I'm going to print p. And again, just like before, I have this variable p in main. I'm going to follow that arrow to this object, and then call its toString. And that will give me 44 and 22, which you can see down there. Chugging right along, on the next line of main, I'm going to modify the p variable again, or modify what's pointed to by the p variable again. So I'm going to do p.x equals p.y. So I'm going to follow this arrow to see where p points, get this object over here, and then assign x to be the same thing as y. Right? So x is going to be 22 now because that's what y is. All right, we're done with that line now. Then we're going to call mystery a second time. I'm going to go a little more quickly through this just because it's pretty similar to what we just saw. But again, same thing happens. Copy over n, which means copying the 5 because it's a primitive type variable here. And then copying over p, right? Because p is a reference type variable, I copy the arrow, right? Not the array, because the arrow is really what p is. And then we start running mystery a second time, right? So again, this n down here gets set to 0. Again, I take this p down here, I see where it points, and I increment this pointed to object's x value now by 33. So it goes from 22 to 55. And then in the last line of mystery, right, just pretty similar to what I did before, I'm going to do p.x, right? So follow that p variable, see the object it points to, print this x, print this y, and then lastly print this n down here. And that should give me 55, 22, 0. Cool, and now we're done with that second call to mystery. We're going to pop back out because we just finished that. And then in this next line of main, we're going to print out p. Same thing as before, main's going to look at its variable p, see where this reference variable points to, and then call this pointed to object's toString, which will give us 55 and 22. All right, in the next line of main, something pretty spicy happens. So we had this variable n and this variable p. Now we're making a new variable p2, right? It's also of type point, which means that this is now a reference type variable just like p was, right? For the exact same reason. So p2 is this arrow, right, that points to this new point object I've just created that's holding 100 and 200. So that's that line right there. And in this next line, something truly crazy happens. So I'm going to assign p to be equal to p2. So I'm going to back up by one slide. If you aren't super clear on this whole reference type thing, you might think that doing p equals p2 means that I set this point object equal to this one. But as we've seen, that is 100% not what happens, right? Doing p equals p2 means, take what's in p2 and copy it over to p, right? Make p and p2 be the same thing. But p2 is not this point object, right? p2 is the arrow that points, to this point object. So if I copy p2 over to p, I'm not copying the object, I'm copying the arrow, right? So this assignment here is going to change p from an arrow that points somewhere else to an arrow that points now to this object as well. I've copied this arrow over from p2's box into p's box. So make sure you can pause the video and go back, but make sure you get why the diagram looks like this after this line has executed. And then next, I'm going to call mystery for a third and final time from main. Again, we have to set up mystery's variables and arguments just like we did before. So I'm going to copy over n, I'm going to copy over p. Again, I copy the arrow because that's what p is, and then I start running mystery. Again, this n down here is the one that's set to 0. Again, I take this p variable mystery, I see where it leads, I see where the arrow goes, and then I increase this object that I land at's x value by 33. So it goes from 100 to 133. And then in mystery, I do this print I've done before where I follow this arrow for p, print that x, print that y, and then finally print this n down here. And that gives me 133, 200, 0. And then finally, I'm in the very last line of main, and actually the very last line of our entire program. I'm going to print out p, and then print out p2. So when I print out p in sort of the first half of this line, in main, I'm going to see where this p variable points, it lands at this object over here. So I'm going to call this object's toString and get 133 and 200, which you can see in the left half of the output down here. And then for the second half of this print, I'm going to say, okay, it's talking about P2 now. So for this reference variable, I'm going to see where it points, and it just so happens to point to the same object. So I'm going to call this specific object's toString method again and get 133 and 200 a second time down there. And with that, I am done printing stuff, and we are done with this problem. I'm going to let Eric take over and talk to you now about problem 1.2a and problem 1.3a.
So I ended section starting to talk about kind of like the differences between an array list and a linked list, right? So kind of remembering back to 143, we talked about a general idea of a list, which is basically like a structure that has some sort of ordering. You can add and remove from it, from the end, from the middle, wherever you want. You can add and remove from it, and it kind of like grows and shrinks dynamically, right? And we saw that like a list was different than, for example, an array, right? We only knew about arrays in the 142 class or equivalent, in that like it's dynamic in its size, right? But 143 tried to kind of dispel some of the like magic behind how do these lists actually work, and we saw kind of like two different versions. The first version we saw was this thing called an array list, and we said, okay, like yeah, to the client or to somebody using this array list, you're seeing just like the elements get added, and this thing's growing and shrinking, and it almost seems like magic. But then we kind of showed, okay, well, underneath, in order to like implement this behavior, we have to do something with an array and like a size variable, right? So I think we started talking about this like remove front problem. And again, this problem, it says write a method remove front. It takes an integer k as a parameter and removes the first k values. So for example, if we were given this list and I called the remove front of 4, I want to delete the first 4 values here, which are these values, right? So the list, to a client, it kind of goes from this to this, right? If I call the remove front of 4, this is what I want my list to look like at the end. And then right now it's our job to like figure out how do we implement this method, right? Given that we only have kind of like these fields, right? So actually what I'm going to do is I'm going to kind of copy this over. We're just going to use this example for a minute. And we can kind of go over here. And we have, I just kind of copied over the my array list, and we're going to write our solution here. So again, the client view kind of like looks like, let's say that the client view of this list looks like this. Kind of like what I was saying about these array lists is kind of remember, I see something like this as like a client. It looks like there's only 1, 2, 3, 4, 5, 6, 7 values in my list, right? I can add and remove from this. But as an implementer, what we kind of talk about when we say like an implementer view means like what do the actual fields look like? So if you kind of remember, like maybe data will look something like this, but typically it's like a very big array that's kind of underneath here, right? We have a big array because that allows us to kind of like grow and shrink. We want to have like room for more values if we wanted to add more. And we also keep track of a size. And in this case, size is 7. So like in this case, right, what this size kind of represents is like how much of this array do we want to show clients, right? So if size is 7, what we're saying is we're only going to show clients the first 7 values. And the clients aren't going to see any other values, if that kind of makes sense. So yeah, just kind of like remembering, like we want to like, the problem gave us like what the lists look like before and after, but we also want to be like thinking about when we're doing these problems, like what do the underlying fields look like? Because, fundamentally we're going to be working with these fields here. So if we kind of went down to 1.2a, we can kind of, let's start this method here. So it says write a method remove front. So void remove front, and it takes in an int k, and I made it void because it doesn't look like it's supposed to return anything, right? Just make sure to be checking for this stuff, right? We can assume things about the parameter, but yeah, we're gonna kind of take in this int k, and what we want to do is, if this was like the before, maybe let's do like before we had something like this. Then we want to think about like what should it look like after, right? Well, we knew for the client, right, that the before looks like this, and the after would look something like this, right? That's just given in the problem, right? Before is this, after is this. We want to think about like what are the fields going to look like before and after before we even dive into this problem. So this is like a step that I'd maybe say like go ahead and maybe like try to figure this out on your own, or with pairs. If you want to pause this video, you can totally do that and try to figure out like what is the data and the size going to look like after we do this remove front of 4. But I'll give you a hint, right? Or I'll just give you the solution, right? What it's going to kind of look like is we're going to have 42, 3, and 8 here, and maybe there's some more zeros. We can just say like this goes on and on. For example, just say like comma dot dot dot. So afterwards, right, we have 3 values in our array. So those 3 values are going to be at the front of data. And then also, if we thought about like what's the size of this list, it's no longer 7, it's 3 now, right? So thinking about how the fields are going to change is going to help, because that's like the fundamental aspect of these problems, is like changing the fields, right? So really, like what we want to focus on is like this, right? Because as the implementer, we want to make data go from this to this, and size go from this to this, right? If if k is equal to 4, right? Oops, let me say if k is equal to 4, right? Then this is what we want to do. So if we kind of saw this, this 42, we got rid of 8, 7, we got rid of all of these things, right? And this 42 is now in index 0, right? So we can kind of say like index 0 should be 42, which is index 0, 1, 2, 3, 4, right? Index 0 in the result should be index 4 in the original. And then if we said kind of like, index 1, right? So this 3, index 1 in the result should be, we can kind of look up here and we can see, okay, where's 3? Oh, it's there. 0, 1, 2, 3, 4, 5, right? So it should be index 5 in the original. So we kind of see a pattern. So kind of what I'm going to do is I'm going to write this loop that kind of is going to copy over all these values, right? So we can think about, okay, well, what's going to be happening in this loop? Not sure yet. Let me move this down a little bit. 4 dot dot dot. And what we're going to be doing is we're going to say like data at, maybe we'll say like int I is equal to, so we'll have like an I. We can say like data at I is equal to data at I plus k. It's sort of like what's happening here, right? Index 0 in the result after this should be index 4. So that's 0 plus k, right? Index 1 should be index 5. So I want to be assigning, index 0 to index 4, index 1 to index 5. We're going to have this here. So we can take a minute and kind of think about like, okay, well, how many times am I going to do this? Well, there could be a lot more values here. It's kind of like we're going to do this for like every index, like starting at, well, we want to start add I at 0 for sure, right? Because we want to say like data at 0 is data at 4. And then I'm going to say like we don't know the middle condition yet, but we're going to have like this I plus plus here. And we can kind of think about like what's this middle condition, like I is less than something, right? This is where I'd maybe ask like any ideas, like what should this be? In this case, I think what we want to do, so like if we're removing four values, right? Then we're only kind of keeping 3, right? We only need to transfer over these 3 values, and that's really it, right? We don't need to transfer over any other values. So what I'll say is this, I'm gonna claim that this is like size minus k. Because we want to, like, this loop is doing like, this is like transferring values, right? So I want to transfer values. What values do I want to transfer? Well, everything that's not these first 4, right? So everything else in the list, which is why I have this size minus k. So yeah, cool. And then I think that this should be working. We can definitely check it over. I'm going to delete this for now. One more quick thing that I forgot to do yet, or I haven't done yet, is we have to also update size, right? So I also have to say like size minus equals k, right? Because we saw that after we also have to update that other field, right? So that's like a common mistake when working with these like array list type problems is like we're working with two fields, so you have to make sure to update like both of the fields here. So yeah, that would be like the remove front solution for an array list. Yeah, I'd ask for questions, but of course it's just recording. If you have any questions, feel free to post on Piazza. I'll be checking and I will answer them. Cool. Okay, moving on. I wanted to briefly talk about the linked list one, but I do want to give you all like an opportunity to maybe like work on this one like on your own. Now that we kind of know how the remove front works for an array list, maybe you can try it for a linked list. One thing that I wanted to mention though is linked lists, like, sorry, what was I going to say? Like to a client, they kind of look the exact same, right? It just looks like a list that can grow dynamically. It has some concept of an ordering, but from an implementer's point of view, we actually have like a very different structure where we only have one field that keeps track of like a front node, and all of these nodes are linked together. So each node stores some data and a reference to like the next node, right? So this would be a really great place for me to like draw a picture out. But yeah, you're keeping track of a reference to the very front, and then each of those nodes is connected to every other, or like connected to the next node. And that node's connected to another node, and that node's connected to another node, kind of all the way down. So this is like the general structure of like a linked list, right? So we went back over here. I also have copied this over for our convenience. Again, like maybe let's copy this thing over. This is a little bit of a long example, but like if we had this as like our client view, our implementer view might look something like this. And this will really challenge my drawing skills. So let's see, we'll have like a front that points to like an 8 node, that points to like a 17 node, that points to a 9 node, 24, 42, 3, and then 8. So again, right, like our client view would be sort of the same thing as the myArrayList, right? Like we'd have this before and after, but yeah, actually maybe we can do also the before and after for this one. Let's do client view. We're gonna have the same before and after, right? To a client, it's gonna look the exact same. But from an implementer's point of view, we have this is the before. Let's move this over. And then we can think about, okay, like what do we want the after picture to look like if I could actually do this? So after is going to look like what? Let's copy this over. Again, sorry, this is a kind of a hard thing to draw on the computer, but so afterwards what we want this to look like? Well, we only want 42, 3, and 8 here, right? So what it's going to look like for a linked list is like actually all these nodes will be gone and we'll just be left with this, right? The front is now 42, right? The front of that list is, instead of being 8, it's 42. So again, I think sort of thinking about like, okay, thinking about the picture in your head or what the fields are going to look like can really be helpful, because really what your job would be is like, you know, this is again, if k is equal to 4, this is kind of like our client view and implementer view. Let's move this over. And then it's kind of our job to simulate this, right? So I do want to give you all an opportunity to work on this one on your own. What I'm going to do is just show the solution for like removing one value from the front. So again, I'll say like, you know, this is not, actually, let me just delete this. Let's say, I'll just say, let's say we want to remove the first value from a linked, or a, what do we call these things? My linked list. ... So maybe I'll just say, and this is going to be, you know, sort of similar to removing the first k values, but you know, I'm going to let you all try that one on your own. But I will kind of quickly go through just if you wanted to remove the first value. Maybe I'll say like public void remove first. Again, no parameters because I'm just removing that very first value, nothing else, right? I'm not going to remove 4 things. I don't have to take a parameter. And actually what it's going to look like for a linked list, the code is just going to be like, well, we can kind of sort of think about like, okay, if I wanted to just, let's say, again, get rid of this because that's for the other problem. Before we have this, and we wanted to remove the very front value only, then we would have the after looking like this, right? So I want to, instead of front pointing to 8, I want the front to point to 17, right? If I just wanted to remove the very first thing. So we can think about, okay, like, what references are going to change here? Well, none of this stuff, sort of, right? Like, none of that stuff's changing. 17 still pointing to the 9 in the after. 9 still pointing to the 24 in the after here. But the stuff that is changing is now front, instead of pointing to 8, is pointing to 17. Right? And 8's just gone from this list, right? So what we want to do is we want to like say like front is equal to like something else. Like we don't want front to be pointing to the 8 anymore. We want front to be pointing to the thing following 8, right? So I want to say front is equal to the thing following front right now, right? So really what this is going to look like is I'm just going to say front is equal to front.next. Because if I asked you in this before picture, what is front.next? Well, that's this. Let's write that, front.next. Here's this. Again, sorry for these like ratchet drawings, but right, if this is front, then front.next is this node is front.next.next, etc., right? It kind of keeps going down. And that just comes from the definition of these nodes, right? Like the nodes have a next field. Right, and then that node, it has a next field that's of type node, which also has a next field, right? Which has, a next field, a next field, a next field. So really, like that's the whole solution. If what we just wanted to remove the very first value, is I just say front is equal to front.next, right? Because I want to set this variable to this variable, and that's the solution to remove first. But I will let you try the solution to, remove the first k values, which is this remove front that takes in an int k. I'll let you try that on your own. If you don't want to try it, you can always like take a look at the solutions. They are posted now on the course website, along with like some helpful slides that you might want to take a look at for like that kind of trace through some of the problems that we like didn't get to and some of the ones that we did get to for the section. The TAs did a really good job with this, so I would definitely recommend like taking a look at it if you want.